Guys, excuse me, in lesson 6.5, we're going to take today and tomorrow to look at graphs of polar equations. And what we're going to do is we're going to spend some time looking at these by hand. Okay, now, I know I've just shown you, you've seen polar mode on your calculators. Okay, you still have that as a checkpoint. Okay, it can still help you to know if you're doing things right. But I want to look at these a little bit. There's a few little, differences, cool things, of how you connect the dots and whatnot. And if you watch, I don't know if you ever watched some of your polar modes graphed when you graph them on your calculator. There's kind of, I don't know, to me it's kind of neat because they kind of go around in circles and stuff to connect. So, it's not just a straight line or a single curve. It kind of goes around and around sometimes. But we're going to look at some very basic graphs. Now, if I ask you to graph an equation and you don't know what it looks like, we normally go for an XY chart, right? Well, this is our version of the XY chart. Okay. The difference with polar coordinates, we know instead of XY, we're going to be looking for an r comma theta ordered pair. Okay. But we're going to use theta as our inputs. So this is kind of a backwards ordered pair, if you will, because normally for an ordered pair, we think r comma theta, but theta needs to be our input to figure out what r is. Now, as you look through those theta values, do those look familiar to you? Those are basically the theta values we see on the unit circle on thing. Okay, they're the basics. Now, you'll find some patterns and stuff, so we'll be able to shortcut some things, but do you need to do all of these? Pretty much, somehow or another. Okay? Now, some of this we'll do with a calculator, some of it we won't. Okay, I'm going to ask you to think without a calculator. So we're going to use kind of the unit circle and chart a little bit, but in order to graph them, in all honesty, we're going to have to think decimals a little bit too. So, on example 1, r equals sine theta. So we're taking our theta value and we're putting it into sine. What is the sine of 0? Sine of 0 is what? We're doing this without the calculator at first, and there's 0, right? The ordered pair there is 1 comma 0, so if we're going cosine sine, then it is 0. Okay. What about the sine of pi over 6? It is 1/2. Now, 1/2, that one's easy enough. I know what that is as a decimal. I know how to graph 1/2, so that's not a huge deal, but I will write it on as a decimal. What about pi over 4? What is the sine of pi over 4? Square root of 2 over 2, straight from the chart there. Now, because I'm going to have to graph this, what is the square root of 2 over 2 as a decimal? That's a calculator problem. I'm not expecting you to know that. I'll be honest, I haven't memorized, but I'm the math teacher, so it's one of those random weird things that I know. Yeah. My brain has it memorized as 0.707. Really, all you really need to know to graph it is 0.7, because that's going to be more than enough, isn't it? Okay. What is the sine of pi over 3? Square root of 3 over 2. That's the other decimal we need to grab real quick. What is square root of 3 divided by 2? As I said, my brain knows 0.866, but in all reality, you're not even going to be able to get as accurate as what it rounds to, 0.9. So, okay. What is the sine of pi over 2? It is what? 0. No. It's 1. I don't know if you said that, if my brain said that, but... Okay. Now, okay, guys. What happens with these next three? 2 pi over 3, 3 pi over 4, 5 pi over 6. Yeah, they're in quadrant 2, yes? So these three right here, we're all quadrant 1. these three are all quadrant 2. What do you know about sign values in quadrant 2? They're positive, right? All students take calculus. So these quadrant 2 answers are still going to be the same answers, but positive. Okay, because we're just plugging into sign. I'm not having to add or subtract from anything, so I don't have to worry about the values changing. So the sign of 2 pi over 3 is the same as the sign of pi over 3, right? Understand that connection. So it's square root of 3 over 2, or that 0.866 number if you want. What about the sign of 3 pi over 4? It's going to be the same as pi over 4, so square root of 2 over 2, or the 0.707 number. Sine of 5 pi over 6, it's the same as pi over 6, so it's 1/2. Okay, what about the sine of pi? It's going to be 0 again. Okay. Now, quadrant 1 was positive, quadrant 2 is positive. These next 3 angles represent quadrant 3. What do we know about the sign of angles in quadrant 3? It's going to be negative, yes? All students take. So now we're in quadrant 3 where tangent's positive, but sine is negative. So that means I know my answers here are all going to be negative. So the sine of 7 pi over 6 is the negative 1/2. Because again, it's my pi over 6 angle, right? The sine of 5 pi over 4, negative square root of 2 over 2. And the sine of 4 pi over 3, negative square root of 3 over 2. What about the sine of 3 pi over 2? Negative 1. And these next 3 are quadrant 4. What do we know about quadrant 4? It is negative, yes? And keep in mind, could you grab your calculator and just plug in sine of 5 pi over 3 as long as you're in radians and get this answer? Yes, you can. Okay, and on some of those, that's what we're going to do. But I'm also trying to work with you guys about knowing your unit circle stuff. So sine of 5 pi over 3 is going to be the negative square root of 3 over 2. Sine of 7 pi over 4, negative square root of 2 over 2. And sine of 11 pi over 6, negative 1/2. What about the sine of 2 pi? It's 0, yes? Be smart. 2 pi is the same angle as 0. Okay, so that should come up, but it's just kind of our ending point as we connect these points. Okay? So, there we go. From here, it's just a matter of graphing them. Okay, I say just, but you know, it really is. As I said, any of these values could have been plugged into the calculator. Just make sure you're in radian setting, and you know, you could have gotten those. Now, as you can see, my graph's on the next page. You have yours on the same page, thankfully, right? Okay. Start at the top. Go in order. Okay. 0, 0. We got it, right? Now, unfortunately, it's kind of the way it works, but our biggest number on here is 1, isn't it? So we're going to be keeping everything pretty small. Depending on scenario, could you maybe, what's the word I'm looking for? Relabel your rings so that they count different. I'm not going to here, but you could. What's the word I'm looking for? I have a word I'm looking for, and it's just not there in my brain right now, but when you count by something other than ones, right, and you relabel it so that you're saying what you counted by. But, okay, so then, now what? Pi over 6 and 1/2. So what are we going to do? We're going to go to the pi over 6, and we're going to go out half a ring. Pi over 4 and 0.7. So you're going out a little bit farther, yes? Pi over 3 and about 0.9. Pi over 2 and 1. Okay, are you seeing something here? Keep going. 2 pi over 3 and 0.9. 3 pi over 4 and 0.7. 5 pi over 6 and 1/2. Pi and 0. Don't we already have that point? It does. It just means that we're overlapping there, and we're going to go through that point again. Okay? So it means that we go through that point. Now, what's our next one? 7 pi over 6, negative 1/2. So where's 7 pi over 6? That's down here, right? But where's negative 1/2 going to take you? Is that taking me to a point I already have? Yeah. Okay. Okay, so that dot's over there. I don't really need to make a dot on top of a dot. 5 pi over 4 and negative 0.7. Well, guess what? 5 pi over 4 is right here. Negative 0.7 takes me backwards through the pole to a point I already have. Okay. Don't assume. Just keep checking. 4 pi over 3, negative 0.9 takes me to a point I already have. What about 3 pi over 2? 3 pi over 2, negative 1 is going to take you up to this positive 1 I already have. Okay, well, 5 pi over 3 is down here. Negative 0.9. Follow through. I already have that point, yes? 7 pi over 4, negative 0.7. 11 pi over 6, negative 0.5. 2 pi comma 0. Okay, so in reality, we really only need to go through 0 through pi. But did we know that? We didn't necessarily know that. Okay, so connect your dots in the order that they were graphed is what I would usually say. And essentially this graph ends up being a circle. Okay. Were you guys able to squint and read those markings on your angles okay, or should we have written them in? I just realized I looked at mine, and I had gone through and written them in because they are, I'm going to give you credit, they are hard to see. I just sometimes don't know, is it my old eyes versus your young eyes, or are they just little blobs? Okay, so something you could have done, this was 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi, 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, and 11 pi over 6. By all means, feel welcome to do that anytime you need to. Okay, obviously, I have graph paper I'm going to give to you when it comes time to do the homework. I'm trying to remember, I think, yeah, they're more readable on the graph paper. Okay, so you shouldn't have an issue there. You should be able to actually see them. Okay. to totally waste the last 5 minutes. You want to go ahead and start filling this next one in? Now, I have to go back, of course. Let's go ahead and see what we can get done here. What's going on here? Yeah, this time it's cosine theta, but it's 2 cosine theta. Okay? So with that in mind, it's cosine theta and then multiply by 2. Now, I don't know. It's because it's just 2 times these things, it's not hard to just do like we did the last one without the calculator. But there'll be some in homework that you'll need to use calculator for. It'll be easier to. I get it. Okay? So, what is the cosine of 0? Yeah. Cosine of 0 is 1, and 2 times 1 is 2. Okay? The cosine of pi over 6 is square root of 3 over 2, but then when you multiply that by 2, you're just going to get square root of 3. I personally know square root of 3 to be approximately 1.7. I guess in my notes I put 1.732, but, you know. Cosine of pi over 4, square root of 2 over 2. When you multiply that by 2, you're going to have square root of 2, 1.414. Cosine of pi over 3 is 1/2 times 2 is 1. Uno? Okay.
That's what I said.
What's the cosine of pi over 2? 0 times 2 is 0. Okay. Now, we can still use this philosophy. What do you know about the next 3 angles? Yeah, these first 3 were quadrant 1. These next 3 are quadrant 2. What do we know about quadrant 2 in this particular problem? Yeah, all students. So sine is positive, but cosine is negative. Okay, and we can still work with that because it's just times 2. Again, when you have to start, like there's one on the back where you have to add 1. Okay, well that just changes things altogether. So 2 pi over 3 is going to be the same answer as pi over 3 except negative. 3 pi over 4, same answer as pi over 4 except negative. 5 pi over 6, same answer as pi over 6 except negative. What about 2 cosine pi? Negative 1 times 2 is going to make it negative 2. 7 pi over 6, the next 3 are quadrant 3. What do we know about quadrant 3? Tangent, so they're all going to be negative again. So negative square root of 3, negative square root of 2, and negative 1. What about 3 pi over 2? 0. And what about these last 4? Or these last 3 so far, I guess. Quadrant 4? What do we know about quadrant 4? It's our C quadrant. It's our cosine quadrant. So these are positive values. So, dang it, thought I'd get it. We're going to have positive 1, positive square root of 2, positive square root of 3, and 2 pi is going to have the same answer as 0, which is 2. Okay, guys, we'll graph these tomorrow, and we'll catch up those that we're missing. We've got 2 more graphs to practice on the back, and then you have 6 graphs of homework. Okay?